All right, let's try a different method. This is the list method, and probably the easier of the two methods. But we're going to actually go and try prime factorization now. Now remember, we already did 9 and 12 once. That was our first example. We know it's 36. And that's okay that we know it, because it's nice to have sort of an idea of where we're trying to go with this when we're done. So I'm going to make my factor trees for 9 and 12. How am I going to factor 9? Well, 3 times 3 is about the only way I can do it. And so I have 2 prime numbers. I'm going to write my prime factorization down here. And it's very important that we rewrite those things out. 12, let's go with 6 times 2. 6 times 2. 2 is a prime, so I need to factor out my 6, which would be 2 times 3. Another prime, another prime. So I would write this, remember, least to greatest, 2 times 2 times 3. Now, I recommend when you do this to write the numbers on top, the 2 prime factorizations on top of each other. So I'm going to rewrite this here in the middle. And I'll show you why I want to do that here in a second. Okay. When we did greatest common factor, we took only the numbers that the 2 factor trees shared, multiplied them together, and that was our greatest common factor. But remember, we're looking for a number that's bigger than 9 and bigger than 12. Okay? Or it could be the same number, but we're looking for a number that's either equal to or bigger than 9 and 12. So what we're going to do this time, we're going to circle any numbers that are shared. And in this case, they share 3. We're going to use every prime factor except for anything that's shared. We're only going to use it one time. So for example, there's a 2 and a 2 right here. We're going to include 2 times 2. There's a 3 right there. We're going to include times 3. Now, looking at this, we're not going to put 2 3s down here because they share those 2 3s. We're only going to count it as 1 3. Anything that's shared, we're only going to use one time. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Now, if we go back and look, we can go back and check our answer from our list. And we found out that 36 was the least common multiple. Again, to refresh you, anything that is shared, like the 3 and the 3, instead of using them both, we only count them once. And that's how we'll do it. Everything else that's used that's not shared gets thrown in. So when we did greatest common factor, we're using only the numbers that are shared. In this case, we're using everything, but we're only using the shared items once. Let's try another example. I know this could be a little bit more tricky than the last time, than the list session that we did. We're going to find 6 and 10. Remember, when we did this with our list, it was 30. So we're going to try to hopefully come up with 30 here. We'll do our factor tree for 6 and our factor tree for 10. We can factor out 6 as 2 times 3. And lucky for us, those are both prime. 10, we can factor it out as 5 times 2. And again, lucky for us, they're both prime. If I rewrite these things least to greatest, looks like this. And like I said, it just seems to me it makes more sense to write these one on top of the other. If you do this, it's much easier to find the similarities. They share a 2. So instead of putting 2 2s, I'm just going to put 1. There's a 3 here, so I'm going to include that. There's a 5 here. I'm going to include that. 2 times 3 is 6. 6 times 5 is 30. So the least common multiple then is 30. Let's go back to our list. Oops, one more. And sure enough, our least common multiple was 30. Remember, you only use the numbers that are shared one time, and then everything else gets piled in. You give it a shot. You try this one. Try 14 and 18. I switched these. They're not the same ones that you did before. They're 14 and 18. So try this, hit pause, factor them out, and see what you get. Okay. Remember, your factor trees aren't going to look identical to mine, and that's okay as long as the numbers at the very end match up. Let's factor 14. I'm going to factor this as 2 times 7. Luckily, 2 and 7 are both prime numbers, So 2 times 7, that's my prime factorization. 18, let's go 6 times 3. Maybe you chose 9 times 2, that works. 3 is a prime number, so I'm going to go ahead and factor out 6 is 2 times 3, which gives me 2 prime numbers as well. So 2 times 3 times 3 is the prime factorization. Again, if I write these on top of each other, it helps me to see what they share. And in this situation here, 2 is shared, so I'm only going to include that one time. I'm going to put 1, 2. Instead of the 2, I'm only going to put it once because it's shared. There's a 3 and a 3 here, so I'm going to do times 3 times 3. And there's a 7 there, so I'm going to do it times 7. Okay, so now we can multiply across to see what we get. 2 times 3 is 6. 6 times 3 is 18. And 18 times 7. Now, hopefully, if you're sitting there thinking that to yourself at home, you've said to yourself, 18 times 7. I'm not sure what that would be just right off the bat. Maybe I should write it out. And if that's the case, good for you. If you sat there and stared at it for a long time, that doesn't help you. Anytime you're stumped like that, do the math out. 8 times 7 is 56. 7 times 1 is 7. Plus 5 is 12. And as a matter of fact, the least common multiple for 14 and 18 is 126. It's a little bit more complicated than finding factors. The good news is, after we've done some practice with this on homework, when it comes to quizzes and tests, it doesn't matter what method you use, whether it's the list or factor trees. If you have any problems or any questions, please stop in and see me before school, grab a lunch pass and come down and see me at lunch, or swing in after school. Hope you guys learned something today, and we'll see you later.